Okay, good evening, everybody. So, can you hear me? Can you see me? Can you hear me? You can unmute yourself and respond. Can you hear me? Can you see me?
Yeah, we can hear you.
Okay, great. Okay, so as you know, so today is our first class on grade 11. So I hope like most of the students are from 2021 always, so it's mainly grade 11. So, but according, because of the current situation, like we know most of the students did not cover, I mean, mainly because of the school. When it comes to all levels, like most of the students depend on the school. So unfortunately, because of the current situation, many students could not complete the grade 10 syllabus. So actually, doing this online is not that easy. So like, because, you know, like when teaching students, if it is face to face, it is much more easier. So anyways, like we have planned to cover the grade 10 syllabus, I mean, revise the grade 10 syllabus together with grade 11. So this thing we do yearly, I mean, on physical basis. So, but this time, the first time it is going to be online. So last year, like the 2020 batch also did like half of the time they did online. So there's around 65 students face the exam. So all those students, most of the time, most of the time, they attended the class online. So anyways, we were able to complete the syllabus successfully. So I hope for you guys also, like we can go, like we have, like if the next exam is scheduled on December, we will have 7 months. So within 7 months, because in previous years we had almost 1 year to do this, but this time we have only 7 months. So in that case, sometimes we might have to extend our classes. I mean, generally our classes will be 2 hours, but since because of the time limit, sometimes we might have to extend our classes. So maybe 3 to 4 hours in the future, in the coming days. So I have planned, I have already mapped your syllabus with grade 10, 11. So like, you know, like for example, when you come to geometry, you have circles. So related to circles, there will be one question in your paper. And in that question, there will be several sections, right? From grade 10 and grade 11 combined. So it's not going to be from one lesson, one question. So likewise, according to your paper, I have mapped and like categorized those lessons together. So this is how I am planning to complete grade 10 and grade 11 lessons together. So similar lessons from grade 10 and 11 will be, I'll try to cover them together. So today is the beginning. So this month we have two more days. So after that, it comes to April. So from April, we will be having 7 months to go through our journey. So that is about the classes. So the class will be every Sunday, and it will be every Sunday at 7 p.m. So I mean, even if I change, I will take a vote, and I mean, if there's any requirement. But as of now, the class will be every Sunday at 7 p.m. Okay. So first of all, let me tell about me. So I am an aeronautical engineer. So I'm working as an engineer at, maybe like it's a Chinese company called Alibaba Group. So I'm working in that company, and on weekends I do classes for students, mainly LOLs and O-levels. Yeah. So mainly LOLs and O-levels. So that is about me. And also, like in our sessions, one important thing is I'm allowing you guys to unmute anytime you want. So please make use of it. So do not make any disturbances. If you make any disturbances, you will be removed from the session and you won't be able to attend again. So that is about the classes. So grade 10 first lesson. So our grade 10 first lesson is maybe some of you have already covered real numbers. Okay, so when it comes to real numbers on grade 10, like we do not have any lesson which directly relates with real numbers. So, but this is the base of mathematics. So I don't know why they have put in your syllabus like in grade 11. So this should be the beginning of grade 10 only. So anyways, real numbers is like the base, everything about numbers. You will be learning everything about numbers under real numbers. So if I talk about the grade 10 lessons related to this, I will put square root. Square root is somewhat going a little bit closer with this, but still this is a standalone lesson. But still in your final paper, you won't be getting any question, direct question from this real numbers lesson. But still it's a very important lesson because it teaches you many simplification and calculation points. Okay, so real numbers. So what are real numbers? So if there's something called real numbers, there should be unreal numbers also, right? So that means numbers which are not real. So like suppose, like 1, 2, or like 1.4. So all these are real numbers, right? I mean, real numbers. When you say like 1, you know what is 1, right? 1. Then 2 or like 0. So these are real numbers. These numbers are actually there. So then what are unreal numbers? The name I'm using, like it's a hypothetical name, but still, what are unreal numbers? So square root, right? Square root. So square root of 4 is going to be 2, right? Because 2 times 2 will make 4, right? Or square root of 9 is 3. So because 3 times 3 will be 9. So if I tell something like square root of minus 1, square root of minus 1, so we cannot find a square root of a negative number. That means there's no negative number. These are called complex numbers. These are called complex numbers. Square root of minus 1. We cannot imagine. There's nothing called square root of minus 1, but still in mathematics, we will be using these complex numbers. But in your O-level syllabus, we do not have these complex numbers. So you are lucky here. We do not have complex numbers. That is out of the scene. We only have real numbers. Okay, so when you go for your A-levels, you will be learning about these complex numbers, which does not belongs to real numbers. But here in your O-level syllabus, we will be learning only about the real numbers. Okay. So when talking about real numbers, we have our symbol. We write it, we represent it with a R. But here we use draw another line here to represent. It's a Greek letter actually. So this is the symbol of real numbers. Okay, so all the numbers that can be represented in a number line, number line, right? So when you take a number line, you have 0, -1, -2, or 1, 2, it will go to infinity. So any number that can be represented in a number line is called a real number. So these all are real numbers. Okay, so when talking about real numbers, let's go from the base. Okay, so we will be going from the base. First thing, okay, you can write down the topic like real numbers, and we can write the symbol in front of it. Okay, so first, counting numbers, right? Counting numbers. So when you say counting numbers, from the word itself, you can guess what are counting numbers. The numbers that you are using to count, right? Count something like 1, 2, 3. Okay, so you won't be using decimal numbers to count, right? You won't say it is 1 point, like you won't use those things to count. So you will be using counting numbers. So counting numbers will consist of like 1, 2, 3, 4. So these are the counting numbers. So counting numbers will also have another name. So for these counting numbers, we also call natural numbers. Natural numbers. So natural numbers are also called the counting numbers. Okay. So every number, so you know, you have learned there's something called sets, right? So every number, so this we have a, for natural numbers we have a notation, right? So we can write the notation of natural numbers n, right? The notation of natural numbers is n. So the set of, so we can write equal, and a set is represented within curly brackets. So you can write within curly brackets, you will write the set of natural numbers you can write. The set of natural numbers will consist like 1, 2, 3, 4, and you will put some dots to show that it will be continuing. So this is the set of natural numbers. Okay. Then after natural numbers, we will be having the integers. Okay. So natural numbers, you can see we don't have 0. We don't have negative numbers, right? We have only positive numbers, 1, 2, 3, 4, and so on. But when you talk about integers, these are called natural numbers. Natural numbers. Next, we have integers. Integers. So what are integers? So integers are the whole numbers, but it can be negative as well as positive or 0. So all the numbers. So the symbol we are using for natural numbers is Z with another line. So Z is equal to the set of natural numbers. So we will be having minus values and 0 and also 1, 2, 3. Likewise, we will be having numbers. These are called the integers, the whole numbers. Okay, so integers also can be two types. So integers also can be two types, like you have positive integers or you have the negative integers. So there's no special symbol for positive integers. There's no special symbol for positive integers, but you will write Z and you will denote it by a positive mark here. So that will be positive set of positive integers. So that will be 1, 2, 3, 4, and so on. Then the set of negative integers, you can represent all the negative integers like this way, -3, -2, -1. So these are the set of negative integers. Okay, so now we know natural numbers, integers, and positive integers, and the negative integers. Okay, so these counting numbers also, you have other sets, right? You know what are odd numbers, then you have even numbers, then you have triangular numbers, which you learned in smaller grades, then you have square numbers, then what else? You have prime numbers. So all these numbers belongs to the natural numbers. Then also we have these things. Okay, the most important one. Next, we have the rational numbers and the irrational numbers. Rational numbers and the irrational numbers. So first, let's go through what are rational numbers. Rational numbers. So the notation of rational numbers is Q. Okay, you'll present with a special Q. Okay, so rational numbers. Any number any number that you can represent as a fraction. Any number that you can represent as a fraction. So the set of rational numbers will be what? A divided by B. So if you can represent a number, if you can represent any number as a fraction, this is a fraction, right? A divided by B, A over B is a fraction. So if you can represent any number as a fraction, that is called a rational number. So what is A and B? A comma B belongs to, okay, this symbol is belongs to, this is set notation, okay. So A divided by, first you write what is A and what is B. Here you can see we wrote the set notation as elements, right? 1, 2, 3, okay. So this is another way of writing set notation. So here we write A divided by B. Q is A divided by B, okay. Q A divided by B such that A and B belongs to integers. A and B belongs to integers, okay. A and B belongs to integers, and there's another condition, and space is not enough, so let's make it. Q is equal to what? Again, A divided by B such that A comma B belongs to integers and B not equal to 0. B cannot be 0. So this is what you call by rational numbers. For example, A divided by B, 1 divided by 2, it's a rational number. If you say 7, you know, you can write it as a fraction. So denominator will be 1. Then you can say 10 is a fraction. You can represent it as a fraction or a decimal number. Like suppose, okay, we will go through them later. Okay, so these are called rational numbers. Okay, so then why do they say not equal to 0? Why B cannot be 0? Why B cannot be 0? Okay, so the denominator of any number, denominator, we cannot divide a number by 0, right? So if someone say like, okay, 0 divided by 5, okay, so I don't have any mangoes, but I'm going to divide that into 5 among 5 people. One person will get how many mangoes? 0, right? So 0 divided by 5 is equal to 0, no problem. So A can be 0. A can be 0, but I cannot divide a number by 0, right? If I say 5 divided by 0, what will be the answer? 5 divided by 0. Some say 5 divided by 0 is equal to infinity. 5 divided by 0 is infinity, but this is wrong. This is not actually correct. Why? Okay, so 5 is a number, okay? Then, okay, let's say you have a number, right? You have 100, okay? So 100 you divide by 10. Your answer is how much? 10, okay? Then again, you 100 divide by 1. Your answer is 1. Then 100 you divide by 0. Sorry, this is going to be 100. Then 100 you divide by 0.1. You will get 1000. Then again you divide 100 by 0.01. You will get 10,000. You divide 100 by 0.001. You will get 100,000, right? So you see, when the denominator is decreasing, when the denominator is reducing, the answer is reducing, right? Answer is increasing. When it is 10, the answer was 10. When it's 1, answer was 100. When it's 0.1, 1000. When it's 0.01, this much, this much, right? So that means when the denominator is going to 0, when the denominator is reducing, our answer is also increasing, right? So that is why people say That is why when the denominator is reducing, our answer is increasing. So that is why people say 5 divided by 0 is equal to infinity. But in reality, we have a problem here. What? We know if someone say the number 1, we know it is positive 1. Okay? If someone say like this, we know it is negative 1. But 0, is it positive or negative? Is it positive or negative? We don't know, right? Because you say whenever you do division, you always have to check the sign. 4 divided by 2, positive divided by positive, you get 2 as the answer. 4 divided by 2 minus 4 divided by 2, minus divided by 2, minus divided by positive, you get minus 2 as the answer. So when you do division, you always have to check the sign first, right? Whether it's positive divided by positive, positive divided by negative, negative divided by positive, or negative divided by negative. So you have to always check the sign, right? But when it is 0, we don't know its sign. Okay, we don't know it is sign. Someone can say, yeah, 0 is positive. No, you cannot say like that. Someone can say 0 is negative. No, still you cannot say that. So whether 0 is here, right? So in the number line, 0 is here. So from this side, it is from here to this side, it will be negative, and on this side, it will be positive. So does it like a little bit positive? Yeah, can be a little bit positive. Or like a little bit negative? Yes, can be a little bit negative. But a lot of negative? No, right? I mean, maybe like positive? Yeah, it can be positive. But no one can say 0 is positive always or 0 is negative always. Okay. So what if 0 is positive? If 0 is positive, you will get positive 5 divided by positive 0, you get positive infinity. But if 0 is negative, what the answer you get? You get negative infinity, right? You get negative infinity. So that is why people say, we cannot, because you have two answers, the negative infinity and the positive infinity, which is on two opposite sides. So we do not have a direct answer, right? So 5 divided by 0 can be positively very high, large number, or it can be negatively a very large number. The difference is too much, right? So it has two answers, 5 divided by 0 for plus or minus infinity. So that is the reason I wrote here not equal to 0. Okay, this is what I just explained you is not in your syllabus. Just for your information, I told this. Okay, because you know, like some teachers, mathematics is not a subject that you need to memorize. You should always ask why. Okay, so whenever you learn this, you write this, right? A divided by b, a comma b belongs to curly z, and b not equal to 0. Then when someone asks why, the teacher will be like, yeah, it's like that. It's not equal to 0. We cannot divide a number by 0. Why? So this is the why. Okay. So this is why we write b not equal to 0. So when we divide a number by 0, it can be positively very large number, or it can be negatively very large number. We don't know whether it's positive or negative. Okay. So that is why we write b not equal to 0. So then let's come back to rational numbers. So in rational numbers, any number that we can express as a fraction is called a comma b. Then a and b are integers, but b is not equal to 0. In this case, this is called the rational numbers. Okay, so I want you to write down this thing in your book. So I hope you got the writing book. So let's write down natural numbers, the example set, integers, the example set, then what are positive integers, and what are negative integers. And then we have rational numbers. Also write down the rational numbers. Then we can explore more about the rational numbers. First write it down. Okay, so one thing I have to tell you is like mathematics, like O-level mathematics is like most of like you are afraid of mathematics. So like at the beginning itself, I'm telling you, so this is like beginning of grade 11, right? So there's nothing to worry about mathematics. The only thing you have to do is more practice. So if you do more questions, that is the best thing. So there's very, very less things to memorize, but still only thing is you need to do more practice. So this textbook, the textbook of your school, the textbook given by government, this is the most important thing like in your O-level career, right? Because you have the government has given you this textbook, right? So they will not give you any question out of this textbook for your final exam. But when you go to A levels, there is no textbook. There is no textbook, but only there is a syllabus. Okay, so that means they can ask anything in this world under that topic. Okay, so it doesn't have to be in like they don't have a fixed syllabus, but in your O levels you have the textbook, right? So out of this textbook they are not giving you anything, right? So the only thing you have to do is go through each and every exercise. So if you can do each and every exercise in your textbook, that's it, you're good to go, right? So that your textbook is the most important thing when it comes to your final exam. So mathematics is not difficult at all. I mean the O-level mathematics. Okay, so this lesson is kind of, yeah, the first lesson, the real numbers. This lesson is like more of like kind of boring. So, but still like you have to learn because like less application, less questions in this lesson. So it's kind of boring, but still like this is the base of mathematics. Okay, so rational numbers, I told you A divided by B is this, right? So any number that can be expressed as a fraction. So it can be a whole number, 4. 4 can be expressed as a fraction. So which is 4 divided by 1. Okay, so that is a rational number. Then let's say this is a whole number. Then we have, let's say 4.1. 4.1 is a decimal number. So we call this type of decimal numbers as terminating decimals, or that's a finite decimal. So this is not going like this, not recurring. I mean, this is only one decimal place is there, then it is going to stop there, right? So these type of decimals are called finite decimals. So this we can express as a fraction, 41 divided by 10, right? So 41 divided by 10. So I will give you a little bit basic information. So like if you say any number, let's say 55 divided by 10, whenever you divide a number by 10, you will go one decimal backwards, right? So that means 5.5. If you divide by 100, you will go 2 decimal places backwards. If you divide by 1000, you will go 3 decimal places backwards. So likewise, I can write 41 as a fraction, that is 41 divided by 10, right? So those are, that one also I can express as a fraction. Okay, then what about 1 divided by 3? 1 divided by 3. 1 divided by 3 is what? You can see 1 divided by 3. You have 0, then you have, for 10, you have 3. 3 times 3, 9, 1, 0, 3. Then this is going to continue forever, right? 3, this will never stop. 1. So likewise, it is going to go 0.333333. It is going to continue for forever. So I can write 3, 3, 3, 3, like that. It's going, right? So this is not a finite decimal. So this is called a finite decimal. So a finite decimal can be expressed as a fraction. Also, 1 divided by 3 can be a finite decimal, right? So in your syllabus, you don't have it's not there to convert a recurring decimal. We call this type of decimals as recurring decimals. So this we can express as 0. recurring 3. We are going to keep a small dot on the top of the recurring number. So this is going to repeat forever. So this type of decimals are called recurring decimals. Recurring decimals or recurring numbers, right? So this 3 is recurring, right? It is going to be 0.3333. It is going to recur till forever, right? So these are called recurring. And if this is finite decimal, this type of decimals are going to be infinite decimals. This is finite, this is infinite. So those are the 2 types of decimals. So both, you can see both the finite decimals and recurring decimals we can express as a fraction. So both of them belongs to rational numbers. So 1 divided by 3 or 0.3 is going to be a rational number. So this finite, this 4.1 is also going to be a rational number. So yeah, so these are the examples for rational numbers. Once again, any number that you can express as a fraction is called a rational number. Then we have irrational numbers. Irrational numbers. So if rational numbers means the numbers that I can express as a fraction, right? Any number that I can express as a fraction is called rational numbers. Then what are my irrational numbers? The numbers that I cannot express as a fraction, right? Obvious, right? If rational means can express as a fraction, then irrational means cannot express as a fraction. So what are the numbers that I cannot express as a fraction? Suppose we have square root 2. Okay, square root 2, the value of square root 2. You can, you can use a calculator to find. If you use a calculator to find square root 2, you will get a very long answer. Even in your textbook, I think it's there. 1.4142135 and it is going to go forever, and there is no pattern. And it's not, none of the numbers are recurring. So this is going to be different numbers. So if it was something like this, if the answer was something like this, 414 414 414 414. So something like this. Okay. If the answer was something like this, 414, 414, 414. So you can see 414 is repeating, right? 414 is repeating. So in that case, this is a rational number. Why? The same set of numbers are repeating, right? So this is a rational number. But if you use a calculator to find the square root of 2, the answer you will get is something, no pattern at all. There will be no pattern, but different numbers, 4, 1, 4, 2, 1, 3, 5, 6, like that, different set of numbers without any pattern. So these types of numbers we cannot express as a fraction. These types of numbers we cannot express as a fraction. Okay, so these are called rational numbers. These are called rational numbers. So square root of many numbers like square root of 5, square root of 7, square root of 11. So all these numbers are irrational numbers. We cannot express them as a fraction. Okay, then what about pi? What about pi? So pi is a irrational number. But someone would ask me, when we find the perimeter or when we find the area, we use 22/7 as is equal to pi, right? We use pi is equal to 22/7. Then that means I can express pi as a fraction, right? 22/7 means fraction, right? Then why now I'm telling, now this is telling like I cannot, like pi is a irrational number. So pi is a irrational number, but still I use 22/7 as pi. So what is the reason? I mean, if I can express pi as a fraction, it should be a rational number, right? No, it is not a rational number. It is a irrational number. Why I am telling so? So if you find the actual value of pi, it is going to be 3.14 something, very different number. Okay. But this 22/7 is an approximation. This is not the actual value. This is actually not equal, or we can say approximately equal to. Pi is approximately equal to 22/7. It is not the actual value of pi. Okay. So that is why I am telling pi. So this 3.14 something, 3.14159, 159, I can't remember the other numbers. So there's a lot of numbers, non-stop numbers, different numbers coming. But this 22/7, if you divide and check, it will be a rational number. So pi is another rational number. Irrational number, I'm sorry. Pi, even though we use it as 22/7, it is not equal to 22/7. It is actually equal to 3.14159,265, like this. Pi is an irrational number. Okay, so those are the types of numbers. So now let us go through again. So okay, so if this is the set of real numbers, if this is the set of real numbers, okay, so irrational numbers, the notation I couldn't say, right? It is going to be q dash. We don't have a special symbol for irrational numbers. You know, rational numbers is q, right? Rational numbers is q. So q dash means everything that does not belongs to q. So for the symbol for irrational numbers is q dash. Okay. Okay, so then suppose this is the set of real numbers. This is the set of real numbers. This is going to be the set of real numbers, right? So all the real numbers are inside this box. So like I told you at the beginning, I told you there's something called complex numbers. So those complex numbers are going to be out of this box. somewhere around here or somewhere out of this box. But in your syllabus, you don't have to worry about the complex numbers. So the real numbers are inside this box. This is the set of real numbers. Then after real numbers, what do we have? After real numbers, we have the rational numbers. We have the rational numbers. So let me draw a circle, Venn diagrams, right? So I'm drawing a circle. So this is going to be my set of rational numbers. Okay. So inside this circle, I have all my rational numbers. So if all my rational numbers are inside this circle, all my irrational numbers are going to be out of this circle, right? So that means like square root 2 or square root 5 or square root 7 or like pi. So all these irrational numbers are outside the rational numbers set. Okay. So these are my rational numbers. Then I have this is my rational numbers. So inside rational numbers, we have integers. Okay, we learned about integers and counting numbers. So these are my rational numbers. So inside the rational numbers, I have the integers. So this is the set of my integers. And inside integers, I have the set of natural numbers. So I can write the set of natural numbers, the set of natural numbers. Okay, so this is the set of, this is the set of integers, right? So this is the set of integers. Sorry, this is a set of rational numbers, irrational numbers. Then inside that I have rational numbers. So what are counting numbers? What are natural numbers? I have 1, 2, 4, 5. So these are called counting numbers. Then outside of that, I have integers. So integers means, so all the positive integers are natural numbers. So outside that we have like 0, then -1, -2, -5. So all those are called integers. So, okay. Then again, outside the integers, I have the rational numbers which are not integers. So that means what? Like 1.4 or like 5/2. So these are not integers. These are not integers. So those things I can write 1.7, 1.2.8. So those all are rational numbers, but not integers. Okay. So I hope it's clear. If you have any question, you can ask. If not, you can write down. So you can write it down. I'm not giving a note in the form of note, but still you can write in the short form. So a descriptive note is in your book. So this is the short description of all the things. And also here you can see the natural numbers. The natural numbers means inside integers. This is my set of integers. So everything inside this circle belongs to integers, right? So all the negative numbers, positive numbers, everything are integers, right? So then again, then all these are integers, but here I have another natural number which is an integer. So these are called positive integers, right? So natural numbers are also called what? Positive integers. I can write z plus. So these things, positive integers and natural numbers are both equal. We have different names, but still they represent the same set. Okay, so you can quickly write it down. Yeah, if you have any question, you can ask. Okay, so we have some questions on the chat. So the first question we have like, can fractions be represented in a number line? Can fractions be represented in a number line? Yes, of course you can represent a fraction in a number line. Okay, so let me erase this part. So when you check okay, so when you check a number line, okay, so you have 0, 1, 2, 3, or like we have -1, -2, right? We have many numbers, right? So what does this belong? So between 1 and 2. So between 1 and 2, we have decimal numbers 1.1, 1.2, 1.3, right? So if you take this one, if you extract this part between 1 and 2, between 1 and 2, you have semi numbers, right? Like in your ruler. So you'll be having like 1.1, 1.2, 1.3, right? So any fraction, suppose it is 4, sorry, let's say 5 or 3 divided by 2, 3 divided by 2. So 3 divided by 2 means it's a decimal number, right? 3 divided by 2 means 1.5. So 1.5 we can represent in a number line. 1.5 means somewhere around here, right? So any fraction you can represent in a number line. No problem with that. And then we have counting numbers means whole numbers. Yes, counting numbers means whole numbers. The numbers that we are using to count. So like 1, 2, 3, 4, natural numbers or positive integers. So any name you can use. Positive integers, natural numbers, counting numbers, all those are referred to as whole, natural numbers. Okay, then chapter chords of a circle. One student is asking for chords of a circle. We will be doing it like in the upcoming lessons. Okay, so we will be going in the grade 11 lesson order, but together with the grade 10 lessons. So we will be following this order. So in the future class, we will be covering chords of a circle. So don't worry about that. Yeah, angles in a circle also. So angles in a circle, chords in a circle. So all these things, right? All these chapters will be covered. So in related to circles, there's many lessons, like around 4 to 5 lessons in your syllabus. So all these will be covered in together, but one in the future classes. Okay. Okay. So irrational. Another student is asking about irrational numbers. So irrational numbers means any number you cannot express as a fraction. So here you can see we have, this is continuing till forever, right? So I mean, if it is 1.4, you can express this as a fraction as 14 divided by 10. If it is 1.213, you can express it as a fraction 1213 divided by 1000, right? But here, irrational numbers, this decimal is not going to stop. It is going to go till forever. Even if you continue telling it for 2 days, 3 days, 1 month, it is not going to stop. So you can tell these numbers till you die. So 4, 1, 4, 2, 1, 3, 5, 6, like that. You can keep on going on forever, but there will be no stop. So these types of these types of numbers are called infinite numbers. Infinite numbers. Infinite numbers. So these infinite numbers, which are not recurring, will cannot be expressed as a fraction, right? So since they cannot be expressed as a fraction, we call them irrational numbers. We call them irrational numbers. Are all root values? Yeah, if it is not a perfect square, I mean square root of 4 is 2, right? So this is not an irrational number. We have a perfect square. But if it is not a perfect square, then yes, it is a irrational number. All the roots are irrational numbers unless it is a perfect square. Yeah, not ending. Okay. Okay, so next we are coming to surds. Next we are coming to surds. Okay, so anything with this symbol, so with this symbol we call them surds, right? So there's nothing to think much. Anything with this symbol are called surds. So it can be a, or sometimes you also have something called third root, fourth root. I will tell about that later. So square root. So in grade 10 also you have the first lesson that is about square roots. So square root. So anything with this symbol are called surds, right? So, okay. So let's first let's do let's say square root 2. So this is a surd, right? Then okay, so one type of question they can ask you is simplifying surds. Okay, so first thing is simplifying surds. Okay, so if you have something like, let's say square root of let's say square root of 32. Okay, so square root of 32. So I will do something like this. You know this, right? Finding the LCM. For LCM we use something like this. Okay, so I will try to factorize. I will try to find the factors of 32. So to find the factors of 32, I will write 32 here. I will start from the lowest number. So I can divide 32 by 2, right? So I will write 2 here. So when I write 2 here, 32 divided by 2 is 16. 32 divided by 2 is 16. Then again, I can divide 16 by 2. Okay, so 16 divided by 2 is 8. 8 also I can divide by 2. Then I have 2. 4, right? 4. 2 is not a good example. 32 is not a good example. I will take something else. So let me take like 2 times 2, 4 times 4, 12. Okay, let me take 12. Okay, so again, I will try to find the factors of 12. Okay, so again, 12 I can divide by 2, right? So I will get 12 divided by 2 is 6. Then again, I'm going to divide 6, I can divide by 2. So I have 2 again. Then I'm getting 3. Then 3 I cannot divide by 2. 3 I cannot divide by 2. Then I'm going to 3. So 3 I can divide by 3. And finally, I'm getting 1. Okay, so now you have to find for pairs, right? So this is a pair. This is a pair, right? So I mean, there's a couple. 2 2s are there. There's a pair of. There's a couple of 2s, right? So in that case, I can write this same 12. I can write 2 times 2 is 4. So I will write it as a 4 times 3, right? 4 times 3, right? So 4 times 3. Now I am going to write them separately. So it is equal to square root 4 times square root 3. Square root 4 times square root 3. So square root 4, you know, square root of 4 is 2. Square root of 4 is 2. And square root of 3, you don't know. Okay, so you simplified the surd. This is called an entire surd. And now you have simplified the surd. Any questions with this? If not, you can write down. Okay, so next, let's try square root of 20. So after writing this example, try square root of 20 in your book. Square root of 20. I mean, simplify. Express as a surd. You can write simplifying entire surds. This is called an entire surd. Everything is inside. And this is called a normal surd in the simplest form. Okay, so 2 root 5. Let's see. One student is studying 2 root 5. So, I mean, if this finding the finding the factors method is I'm telling it for your easiness, but still you don't. I mean, in calculations you can directly write 12 is equal to 2 root 3. No problem with that. But here, since the lesson is surds, we will be using the steps also. Okay, so square root of 20. Square root of 20. Again, I will find the factors. So 20 divided by 2, I get 10. Divide by 2, I get 5. Then 5 I cannot divide by 2. I cannot divide by 3. I cannot divide by 4. I can divide by 5. I have 5. Okay. So now here also I have a pair. I have a couple. All right. I have a pair. So in that case, I can write square root of 2 times 2 is 4. 4 times 5. 4 times 5. Then that means square root of 4 times square root of 5 is equal to, so square root of 4 means 2. So I have 2 root 5. So 2 root 5 is equal to square root of 20. Okay, next one. This is number 1, this is number 2. And number 3, let's find the square root of 98. Square root of 98. Okay, you can tell me the answer. Okay, 7 root 2. Okay, let's see. So again, I will try to find the factors quickly. 98. So I can divide by 2, right? This is an even number. So I have, for 9, I have 4. For 18, I have 9. 49. Then 49. When it comes to 49, 2 is not possible. 3, I cannot divide. 4, I cannot. 5, no. 6, no. 7, yes. So I can divide by 7. So when I divide by 7, 49 divided by 7 is 7. So I have another 7 here, 7. Okay, so here I have a pair. So this 98, I can write it as what? I can write it as 7 times 7. So that is 49 times, this is for my rough work, 49 times 2. 49 times 2. So then I can write separately square root of 49 times square root of 2. Square root of 49 is 7 root 2. 7 root 2 is the answer. Okay. So this is about simplifying surds, right? That is writing entire surds as surds. Okay. Then we can go to, if you wrote down up to here, next we will go to writing surds as entire surds. Okay. So I hope everyone understood. If you have any question, so can you do? Okay. Okay, so we will be doing big sums, but let's go through the basic idea. Okay, so next, that is the first one. Then we have number 2, writing surds as entire surds. Writing surds as entire surds. That means previously we did entire surds, we converted into surds. Then now we are going to go backwards. So that is easy. So number 1, let's say it is 5 root 2. 5 root 2. Okay. So 5 root 2, when we have to put this 5 inside the square root, right? We need to put this one inside the square root. So when you put the 5 inside the square root, what happens? 5 becomes 5 times 5. 5 becomes 5 times 5. So 5 becomes 5 squared. 5 becomes 5 squared. 5 becomes 5 squared, and 2 is as it is, 2. So now you just need to multiply these two numbers. So you know 5 squared means 5 times 5 is 25, times 2 is equal to 50, square root 50. So that is 5 root 2. Let's try 7 root 3 is equal to what? 7 root 3. 7 root 3 as an entire surge. We have a 147. Okay, so when this goes inside, it becomes 7 squared times 3. So 7 squared is 49. 49 times 3 is equal to square root of 147. Good, that's the answer. Okay, one more question. 4 root 5. One more question, the last one. 4 root 5 is equal to what? Yes, we have an 80. So when 4 goes inside, 4 becomes 4 times 4 becomes 16, right? 4 squared means 16. 16 times 5. 16 times 5 is square root 80. Okay, so we are done with the second one also. Next, addition of surds. So I want you to write down these things also. Addition of surds. Right. So addition of surds, that means adding two surds. So, you know, like if you have, let's say, 5x plus 3x. So if it is something like this, you can always add, right? I mean, if the something in the front, if it is same, it is something like this. So you are going to add 5 apples and 3 apples. 5 apples and 3 apples. You are going to add 5 apples and 3 apples. Ultimately, you are going to get 8 apples. So you were able to add them only because both were apples, right? If one was apple and one was orange, then you cannot get an answer. You cannot add them, right? That is like 5 apples and 3 oranges. You cannot add them. You will have, like, suppose you buy 5 apples and 3 oranges. You buy 5 apples and 3 oranges. Then you will ultimately, if someone asks how many fruits do you have, the answer will be I have 5 apples and 3 oranges. But what if you buy 5 apples and 3 apples? 5 apples and 3 apples. Then if someone asks you how many fruits do you have, you can directly say I have 8 apples. I have 8 apples, right? So that means you can add only if the thing in the front is same. So similarly here we have 5x plus 3x. I have 5x's and I have 3x's. So when I add them, I get 8x, right? So I was able to add only because the x's are the same, right? So if there was something like this, 5x plus 3y, I will never be able to add. 5x plus 3y, I cannot add. I cannot add. I cannot write anything, right? I will have to write the same thing. So like that, surds are also the same. So if the surd is the same, then you can add. So that means if you get something like this, 5 root 2 plus 7 root 2. Okay, so you have, here you can see you have 5 root 2's. That means 5 apples or 5 root 2's and 7 apples. No, 7 root 2's. So you have 5 apples and 7 apples, which will give you 12 apples. No, you have 5 root 2's and you have 7 root 2's. So it will give you how much? Directly it will give you how much? 7 plus 5 is going to be 12 root 2's. So that is the answer. But if you have something like this, so let's say you have 5 root 2 plus, this is the first one, and let's this one, second one. You have 5 root 2 plus 3 root 3 plus 5 root, let's say 2 root 2. 2 root 2. Okay. So then again, the same terms you can add. Okay. So here we have, here what we have? Here we have a root 2. Here we have a root 2. So that means this one and this one I can add, but this one and this one I cannot add. Okay. So my answer will be 5 root 2's plus 2 root 2's will give me 7 root 2. And the 3 root 2 I will have to write as it is, 3 root 3. That will be my answer. I cannot simplify further. This is the maximum I can do. I cannot do anything else because apples to oranges I cannot add. So root 2's and root 3's I cannot add. So this will be the best. This is the best that I can do. So this is the addition of surds. So if the surds are the same, you can add. If the surds are different, if the surds are different, you cannot add them. So let's try one example. 20 root 2 plus 5 root 3 minus 10 root 2. What is the answer? Addition and subtraction both same, right? Nothing to tell about that. Okay, we have 10 root 2 plus 5 root 3. Yeah, so here we have a root 2, here we have a root 2. So we have 20 of them, we have 10 of them. So 20 minus 10, we have 10 root 2. 10 root 2. For 3, we cannot do anything. We will have to keep it like that. Plus 5 root 3. That's the answer. Write it down. Okay, so addition of surds done. Okay, write it down. Next we have multiplication of surds. So again, very simple. So let's say 5 root 3 times 4 root 2. What you have to do is multiply the numbers separately, multiply the surds separately. So the numbers you have 5 and 4, and the surds you have 3 and 2. You have to multiply them separately. So 5 times 4 will be, you will write 5 times 4. So that is the numbers separately and surds separately, times surds you have 3 times 2, right? Here we have a 3, here we have a 2, so 3 times 2. So 5 times 4 is 20, 3 times 2 is 6. You have a 20 root 6. That is the first example. Okay. Let's find this 2 root 3 times 3 root 6. What is the answer? Okay, 6 root 18. So 2 times 3, we have 6. So we have 2 times 3 times square root 3 times 6. So we have 2 times 3 is 6. And we have 3 times 6, right? Okay, so shall we break this into 2? Like we can write 3 times 6. I can write 3 times 2, right? So instead of 6, I can write 3 times 2, right? So here I can see I have a 3 times 3. So that means I can take this 3 times 3 outside. So here I will write 6 times 3 times 3 means square root of 9 times square root of 2. Okay, so I will write it like 6 times square root of 9 means 3 times square root of 2, which is equal to 6 times 3 is 18 and root 2. So 18 root 2. So even if you write this thing, it's okay, but this is the simplest form. So 18 root 2. And one more example. 4 root 2 times 3 root 8. Uh, 6 root 18 is correct without breaking. Yes, it is correct. No problem. Your answer is correct, but always it is better to leave the answer in the simplest form. It will be better, but still 6 root 18, the answer is correct. Okay. 48 root 2. Okay, let's see. So we have 4 times 3 is 12. And we have again 2 times 8 is 2 times 8 is 16, right? So 2 times 8 is 16. So how did you get root 2? Square root of 16. 2 times 8 is 16, right? So square root of 16 is 4. So you have 12 times 4. Directly you can write. Square root of 16 is 4, you know, right? So 12 times 4 is 48. Okay, any questions? Okay, if no questions, we can go to the next part. Division. Same like multiplication. Okay, so let's do 3 root 20 divided by 5 root, sorry, 2 root 5. 2 root 5. 3 root 20 divided by 2 root 5. Okay, so again, division, I mean, you always write it like nowadays we don't use this division mark, right? We always use the fraction form. So let's write it as a fraction. So this thing, this whole thing divided by this whole thing, right? This whole thing divided by this whole thing. So that means 3 root 20 divided by 2 root 5. 3 root 20 divided by 2 root 5. Then from 20, should I write the factors? 20, I can write 2, 10, 2, 5, 5, 1. So I have a this thing. So 2. So I can write it as 2 root 5, right? So times 2 root 5. So root 20, I can write as 2 root 5. So entire third into thirds. Then I have divide by 2 root 5. Divide by 2 root 5. Then what can I do? This root 5 to this root 5 cancel off. Then we have a multiplication in between, right? If we don't write anything in between two numbers, that means there is multiplication. Then this 2 to this 2 cancel off. Then what's remaining? Only 3 is remaining. So 3 is the answer. Okay, so you mean Fatima, I think you're asking about this question, right? So what you're asking, what if we break like previous question, previous part? Okay, let's do it like that. So like 3 root 18, right? So what should I do? I will have 4, I will multiply. 4 times 3 is 12 times square root 2 times 8. Okay, so 2 times 8. So I'm going to break it again because I have a 2 here. I will break it. So 12 times 2 times 8, I can write 2 times 4, right? So here I have a 4, here I have a 4. So this thing I will write 12 times 2 times 2 is 4, right? So that one will be square root of 4 and square root of 4. Square root of 4 times square root of 4. So then again, you are getting the same answer. times square root of 4 is 2 times square root of 4 is 2. So again, you get 12 times 2 is 24. 24 times 2 is 48. Again, you get the same answer. Okay, then division of surds. So division of surds, I mean, when it comes to division of surds, if there's a number like this, a divided by b, you always can write it as a fraction, a divided by b, right? A divided by b is a over b, right? So 4 divided by 2 means 4 over 2, right? 4 over 2. So here also, I did the same thing. So I have one term here, I divided it by the second term. So the first term is the numerator. First term is at the top. Then the second term is at the bottom. So at the top, I have 3 times root 20, right? So root 20, I can write, I'm going to break, I mean, I'm going to write it as a surd. This entire surd, root 20, you know how to make it a surd, right? So root 20 means what? Root 20 you can write, root 20 you can write 4 times, that means 2 times 2, right? 4 times 5, right? So then I get square root of 4 times square root of 5. So then I get square root of 4 is 2 root 5. So that is why instead of root 20, I wrote 2 root 5. Okay. So instead of root 20, I replaced this root 20 with 2 root 5. I replaced the root 20 with 2 root 5 because both are the same. So then I got 2 root 5. Then I was able to cancel off because I have the same thing at the denominator. So you know, when there is a number, same number at the top and the bottom, and multiplication in between, you can cancel off, right? You can cut. Like if you have something like this, you know, right? 4 over 2, right? 4 over 2, you know how to cut. We have 2 divided by 2 is 1, 4 divided by 2 is 2. So like that you can cut. So here also I did the same thing. So root 5 and root 5. So root 5 to root 5 cancel off. Root 5 divided by root 5 and root 5 divided by root 5. Then 2 to 2 cancel off. So everything cancel off and only 3 is remaining. So that is how I got the answer as 3. Did I make myself clear? Okay, great. Then let's try second one. 3 root 50 divided by 2 root 5. Sorry, not 2 root 5. Wait, 2 root, let's say 5 root 2. 3 root 50 divided by 5 root 2. Let's find the answer. In division, always should we need to write the numerator in simple surd to simplify? Yes. I mean, it will be easy. If there's a root 20 at the bottom, I mean, if you had something like this, 3 root 20 divided by 2 root 20. If you had something like this, then you don't need to simplify. Then you can directly write 3 root 20 over 2 root 20. Then root 20 to root 20, you can cancel off. But here, we do not have a root 20. So we cannot simplify root 20 and root 5 directly. So that is why I took like that. Okay, answer is 3. Let's see. Answer is 3. So we have 3 root 50 divided by 5 root 2, right? So again, 50. You can write like what? 50 divided by 2, 25. I cannot divide by 2. I can divide by 5. So I have a 5, 5, 1. So I have a couple here, 5 times 5. So I can write root 50 as what? 5 root 2. Root 50 will be equal to 5 root 2, right? So in that case, I will replace root 50 with 5 root 2 times 5 root 2 divide by, again I have 5 root 2 here. I purposely gave this number so that it's easy simplification. So 5 to 5 we can cancel off, 2 to 2 you can cancel off, again 3 is remaining. So 3 is the answer. In exams, will they ask which one is rational and which one is irrational number? No, they won't ask. That's too much easy. So, I mean, that's what I told. From this lesson, maybe, no, probably this from SERS, you can get a question like to rationalize. I mean, after this one, you will be learning about rationalizing the denominator. So, or like addition, subtraction of SERS, you can get for the first part. In the first 20 questions you have, 25 questions you have, right? So in that part you might get a small question from this lesson. Other than that, you will not get any big question from this lesson, but still this knowledge is important to do the simplification of other lessons, of the upcoming lessons. So this will put the foundation for the other lessons. Okay, so now we are done with that one also. So now let's go. Okay, next one is rationalizing the denominator. Rationalizing the denominator. Okay, so sometimes you might get like, suppose there's something called something like 1 divided by square root 2. Okay, so 1 divided by square root 2. Okay, so we assume even though root 2 is a irrational number, let's think like root 2 is approximately equal to 1.414. Okay, so 1.414. So if you want to find the answer, it will be approximately equal to 1 divided by 1.414. So this is like kind of difficult, right? This is like, I mean, too much work, right? So 1 divided by, it's like kind of difficult. So in such cases, we can rationalize, we can bring this root 2 to the top. So we are going to bring this root 2 to the top. That means we are going to remove all the irrational numbers from the denominator. We are going to remove the, I'm telling again, we are going to remove the irrational numbers from the denominator and put all the irrational numbers to the numerator. So how to do that? So this thing is known as rationalizing the denominator. So rationalizing the denominator. So the question will be rationalize the denominator of the given number. So let's say it is 1 over root 2. Okay. So, you know, if I multiply root 2 by root 2, if I multiply root 2 by root 2, what is the answer? Root 2 by root 2, what is the answer? Send me on the chat. If I multiply root, or you can unmute and tell me. Yeah. Yeah, 2 is the answer. So 2 times 2 is 4. So you have square root of 4, which is equal to 2, right? So if I root 2 times root 2 is 2. So that is always, that means like root A times root A will give you A. Root B times root B will give me B. So likewise, if I multiply the root by the same root, I will get the number without the root. So I am going to do something. So if I want to remove this number, remove this rational number from the denominator, I can do one thing. I can multiply this number with root 2. So if I multiply this number by root 2, my denominator will be 2, right? So which is a rational number. So there will be no problem with that. But I cannot simply multiply any number as I want. So if I multiply the denominator with some number, I will have to do the same thing to the numerator. If not, the number will change, right? If I do something like, suppose you have a scale, right? So you are going to remove something or add something to one side of the scale. So if you do not do the same thing to the other side, the scale will go unbalanced. So likewise, if you do something to the numerator, you have to do same thing to the, if you do something to the denominator, you have to do the same thing to the numerator. So I multiplied the new denominator by root 2. Why? Because I want to remove the root 2, which is a rational number. So if I multiply the denominator by root 2, so in that case, I will have to do the same thing to the numerator. So if not, numerator will be angry. Okay. So if you do something to the denominator, you have to do the same thing to the numerator. So then what happened? 1 times root 2 is root 2. And then we have root 2 times root 2 is 2. So the answer is root 2 divided by root 2. Now my denominator is rational. So now look, if I assume root 2 is 1.412, then I can easily find the answer. 1.414 divided by 2. I can easily find the answer. It is going to be 0 point something, right? Can we simplify both denominator and numerator? What do you mean by simplify both numerator and denominator? The question is not clear. I mean, what you do is multiply. Now we have root 2 over 2. So you cannot cancel off because this is root 2 and this is 2. So you will have to keep it like that. You cannot cancel off. I mean, if you're asking that, can we cut like 2 to root 2? You cannot do that. This will be the answer. That is it. Your denominator is rational. Your question will be rationalize the denominator. So now you have rationalized the denominator. Your denominator is rational. Your denominator is not irrational. So you have rationalized the denominator. Okay, question number 2. Let's say root 3, 2 root 3 over 4 root 2. Rationalize the denominator. Rationalize the denominator. Rationalize the denominator. Yeah. Yeah, Fatima, you cannot cut like that because this is root 2 and this is 2. So you cannot cut. But you can make it like, if you do something like this, you have root 2 here. So 2 you can write it as root 2 times root 2, right? 2 means root 2 times root 2, right? So this one to this one cancel off. Then you will get 1 over root 2. So 1 over root 2 means again going back to the same, right? Again, the denominator is irrational. So back and forth you can go. So there's no use of cutting it, right? So no use of doing this. Okay, so we have 4 root 2 divided by 2, right? Okay, let's see. So I need to rationalize the denominator. So rationalize the denominator, I have to remove this root 2. So I have 3 root 2, 2 root 3 here. I have 4 root 2 here, right? So to remove the root 2, I will multiply by root 2. I will multiply by root 2. So if I multiply the denominator by root 2, I will have to multiply the numerator by root 2 also. Then I have what? 2 and root 3 times root 2 is root 6. Root 6 divided by, we have a 4 here, and root 2 times root 2 is going to give me 2. So this 2 to this 2 will cancel off. So I will have root 6 divided by 4. Did you get this answer? Root 6 divided by 4. I don't see a correct answer. Or did I make a mistake? So this root 2 to this one cancel off. So 4 is remaining. Any questions? Can you explain the last part? Okay. So let's do it again. So we have 2 root 3 divided by 4 root 2. So they're asking me to rationalize the denominator. So that means remove this root 2. So to remove that root 2, I have root 3 here, 2 root 3, the same thing. Then I have 4 root 2 here. I have 4 root 2 here. So to remove the root 2, I will multiply it by root 2, right? Because root 2 times root 2 will give me 2, right? That means I can eliminate the root from here. Root 2 is a irrational number, right? Root 2 is a irrational number. So if I multiply with root 2, I can remove the root from here. That means I can make it rational, right? So if I multiply the denominator by root 2, what will happen? I will have to multiply the numerator by root 2 also. So then what happened? 2, I don't have any number to multiply by 2 because there is no any other numbers outside the root. So I will write 2 as it is. Then 3 root 3 times root 2. Root 3 times root 2 means root 6. 3 times 2 is 6. Root 6. Divide by 4. I don't have any number to multiply with 4. So I will keep 4 as it is. Then I have 2 times 2. Root 2 times root 2. Root 2 times root 2 means root 4, which is 2, right? So root 2 times root 2 is 2, right? Then what happened? I have a 2 here. I have a 2 here. I can cancel off. Then what is remaining? Root 6 divided by 4. That is the answer. Now my denominator is rational. Now my denominator is rational. If all the values are different, how can we add? We cannot add. If the values are different, if the root values are different, we cannot add. Okay, so that is about rationalizing the denominator. Okay, let's do one more. So let's say A divided by root B. Rationalize the denominator. A divided by root B. Easy. So A and B are integers. You can't we simplify 4 and 2? Yes, you can. No problem with that. So if you use 4 and 2, what happens? Here, if you use 4 and 2, you can simplify 4, and for 4 there is 2. Again, you have 2 times 2. 2 times 2 is 4, and we have a root 6. You're getting the same answer. Okay, so what's the answer for A root B? A divided by root B, rationalize. A root B divided by B, yes. So what can we do? We have A, we have root B. So to remove the root B, I will multiply the denominator with root B. So if I multiply the denominator with root B, I will have to multiply the numerator by root B. So then what will happen? Root B times root B will give me B, and numerator will be A root B. A root B divided by B. Okay, so now let's do a few more examples. Okay, let's do this 3 number example. Simplify. First one, 3 root 63, 3 root 63 minus 8 root minus 8 root 28 minus 5 root 7. Let's find the answer. Let's make it 14. 5 root 14. No, 5 root 7. 5 root 7. Okay. Okay, so we have minus 12 root 7. Minus 12 root 7. Okay, let's see. So 63. What can we do with 63? So 63. So with 2, I cannot divide 63. So with 3, I can divide 63. So I have 21. Then again with 3, I can go. So then 21 divided by 3 is 7. 7 and 7, 1. Okay, so I have a pair here. So I can take that pair outside. So if I take that pair outside, what happens? So 3 times 3 root 7, right? So 63, I can write 3 root 7, 3 and root 7, 3 root 7. Then minus 8. So for 8, what can I do? So 28, I can divide by 2. So I have a 14. Then again, I can divide by 2. I have a 7. Then I can divide by 7. Okay. So I have a pair here. So that will give me times 2 root 7. 2 root 7 minus 5 root 7. Okay. So now I have root 7, root 7, root 7. Initially, I cannot add or subtract them because they are different. Because I had 63 here, I had 28 here, I had 7 here. So they are all different. So I cannot add or subtract them. But when I turn the entire surds into surds, I got root 7, root 7, root 7. So now I can add or subtract them. So then I can write 3 times 3, 9 root 7, minus 8 times 2, 16 root 7, and minus 5 root 7. So what do I get? So I have 9 and plus 9 and minus. So 16 minus 55. So what did I get? 9 root 7 minus 16 minus 5. So I get minus 21 root 7 minus 21 root 7. So I get minus 12. 9 minus 21 is minus 12. Minus 12 root 7. So that is my answer. Minus 12 root 7 is the answer. If you have any questions, you can ask. And then we can try to, let's try 3 root 6 divided by root 2. 3 root 6 divided by root 2 plus root 75 plus root 75 minus 3 divided by root 12. Let's try this. Example 2, simplify. How it comes as 21 root 7. Oh, 21 root 7 because minus 16 minus 5. Minus 16 minus 5. So if you take the number line, what happened? You have 0 here. You have minus 16 here. Minus 16 and minus 5. So minus 5 means 5 jumps backwards. So then you get minus 21. So from these two only I got, minus 21. What happens if we subtract 9 by 16? What happens if we subtract 9 by 16? So you mean if we do this two first, right? This one and this one first, then we go to this one. Yes, you can do that, no problem. 9 minus 16 will give you minus 7. Minus 7 minus 15 will give you minus 12. Same answer. Okay, so we have one answer, 8 root 3 divided by 12. 8 root 3 divided by 12. Okay, let's see. So without adding them, let's try to do it separately. Okay, so this one separately, this one simplifies separately, and we will simplify this one separately. So here I will write 3 and root 6. So root 6 means root 2 times root 3, right? Root 6 means root 3 times root 2. Then divide by root 2. Okay. So this thing, okay. Then we have plus root 75. So root 75 means what? So I have a 75 here. So sorry, 75. So 75, can I divide by 3? Yes, I can divide by 3. So 3, I have 2, I have 5. Then 25, I can divide by 5. I will have 5, then I have 5, 5, then this pair, right? So I have a 5. So 75 means what? 5 root 3. So that means like 5 times root 3. I have 5 root 3 means 75. Minus 3 and 12 also I can break into thirds. So this one also we can break into thirds. So 12, if I break into thirds, what happens? So 12 means 12. So 2, then we have 6, 2, 3, 3, 1. So that means 2 root 3, right? So 2 root 3. So 2 root 3. So we have 2 root 3. Okay, so we can cancel off this one to this one. Root 2 to root 2 cancel off. So now what is remaining? So now what is remaining? We have a 3 root 3 here. 3 root 3 plus 5 root 3 minus 3 or divide by 2 root 3. Then 3 root 3 plus 5 root 3 means same thing, root 3, root 3. So 5 of them, 3 of them. So we have 8 root 3. 8 root 3 minus, okay, so here let's rationalize the denominator. Okay, so what we'll do, so 3 over 2 root 3, I will multiply with root 3. I will multiply with root 3. Okay, so what will I get? Root 3 times root 3 means 3, right? So I will get 8 root 3 minus, oh, so I mean, like, you don't have to follow the same method that I do. I mean, whatever feel you want, like you want to do, you can do, no problem. Because these are simplification, right? It doesn't mean like you should follow this method. So whatever the method you follow, as long as you get the same answer, it is okay. So we have 3 root 3 divide by 2 times root 3 times root 3 means 3. So now 3 to 3 cancel off. So when 3 to 3 cancel off, what is remaining? When 3 to 3 cancel off, we have 8 root 3 minus root 3 divide by 2. Okay, root 3 divide by 2. Then these are two fractions, right? So to add or subtract two fractions, you should have the same denominator, right? So that means if you want to add 1 over 2 plus 1 over 3, you cannot simply add them. You should have a common denominator. That means you will make multiply by 3 and 3. You will multiply by 2 and 2. Then make it 3 over 6 plus 2 over 6. Then only you can add. If you have the same denominator, then you can add. If you don't have the same denominator, you cannot add. Same thing here. Even though we have square roots here, this is still a fraction. This is not, this is a, so here at the denominator we have 1. So here it is 1, here it is 2, we cannot add them. So we have to make this 2, this one a 2. So how to do that? We will have to multiply the top and the bottom by 2. So I'll multiply this one by 2, I'll multiply this one by 2. So I get 16 root 3 divide by 2. 16 root 3 divide by 2 minus root 3 divide by 2. So now we have the same denominator. So now we have the common denominator. Now we can do the simplification. So here also we have root 3, root 3. So that means what? 16 root 3 minus root 3 divide by 2. So now you can see we have a 16 apples here. We have 1 apple here. So 16 apple minus 1 apple means 15 apple. Or 16 root 3 minus 1 root 3 means 15 root 3. 15 root 3 divided by 2. That is the answer. Any questions you can ask? Can't we simplify? Can't we simplify 16 and 2? So you mean simplify 16 and 2 means here, right? We cannot do that. Why? We multiplied by 2, right? Here we multiplied by 2 to make the denominator same. So if we simplify 16 and 2, then what happens? Again, the denominators will be, again, it will go to the previous one. Then we don't have common denominator. Then we cannot do the simplification. So we made this a 2. We multiplied top and bottom by 2 to make the denominator same. So if you simplify this one, then again you cannot add these two because the denominators are different. At the down we have 15 and 6, 2. So 15 and 2 you cannot simplify. Or you mean here? No, you mean here we cannot simplify. 16 is here because this 2 belongs to both of them. So you cannot cut this one and this one. There's a negative sign here. If there's a multiplication, if there was a multiplication here, then you can cancel off. But here it is a subtraction. Because of that, you cannot cancel. And here it is 15, not 16. No, addition also. Even if it is addition, we cannot. Right? So, I mean, for example, we have something like this. 10 plus 3 divided by 3. Okay? 10 plus 3 divided by 3. You can never cancel off this 3 to this 3 because there is an addition in between. So you have to add them, right? So before adding, you cannot cancel off. But if it was something like this, 10 times 3 divided by 3. In that case, you can cancel off this one to this one. So only if there is multiplication. Okay, so even if there is addition, somewhere 10 times 3 plus 3 or something like this, 10 times 3 plus 10 or something like this. Since there is addition at the top, then you cannot cancel off. You can never cancel off this one to this one. Okay, if there is only multiplication at the top, then you can do the cancelling off. Addition, subtraction, nothing. Can't we rationalize the root 2 in first step? Can't we rationalize the root 2? Yes, we can. No problem with that. If you want, you can. It will be different. Like then the flow will change, but you can rationalize root 2 and go forward. No problem with that. That's at all. Like it is not going to, I mean, the way you do, the method you do can be different, but the final answer should be the same, right? The method can be different. So this is the method I followed, but you can follow another method. No problem with that. That is the beauty of mathematics. You can go in a different path. I will go in a different path, but finally the answer will be same. If the final answer is different, then you have done some mistake. You can double check. So if you want, let me do the other method also. So first you can write it down. So let me first rationalize and do. So I'll give you like 1 minute to write it down. Okay. Okay, so if you rationalize first, what happened? So 3 root 6 divided by root 2. So you will multiply by root 2. You will multiply by root 2. Okay, so plus root 75, I think there's no problem. So it will be 5 root 3, right? 5 root 3 minus 3 divided by, then this one also no problem. You have 2 root 3 here. 2 root 3 here. Okay, so then what do you have? So you have 6 times 2 is 12. 12 divided by 2, right? 6 times 2, 12. Root 2 times root 2 is 2. So you have a 2 here. Plus 5 root 3 minus, this one also you can rationalize. So you will have 3 root 3 divided by 6. Okay, so I'm going to skip some steps. So 3 root 3. So you are going to multiply top and bottom with root 3. So then 3 is remaining. So 3 times 2 times 3 is 6. At the top, you will have root 3. Okay. Then what do you have? Here, root 12. You can write 3 times what? 3 times 2 root 3 divide by 2 plus 5 root 3, and this 3 to this 6 cancel off, so we have a 2 here, plus root 3 divide by 2. Okay, then this 2 okay, so since we need a 2 at the denominator, I will not cancel off because we need a 2, right? So here we have a 2. If you cancel off, it will be 1. So I'll keep it as it is. So I have 3 times 2, 6. So 6 root 3. If I want, I can cancel off this one to this one, but I will not cancel off. Why? To add this one and this one, I will need a denominator 2 at the bottom. So if I cancel off, again, I will have to multiply and take it, right? So I will keep it as it is. Divide by 2 plus, then I have a 5 root 3. So 5 root 3, so this is minus. So this one is 5 root 3. So I'll get the common denominator. So 5 root 3 means 10 root 3 divide by 2. Common denominator. I'll multiply top and bottom with 2 to get the common denominator. Minus root 3 divide by 2. Okay, so it look 6 plus 10. What do you have? Is equal to 6 root 3 plus 10 root 3 minus root 3 divide by 2. So 10 plus 6 is 16. 16 minus 1 is 15. 15 root 3 divide by 2. Again, you got the same answer. Yeah, okay. So yes, so we have completed the first lesson. So the first lesson is complete. So in your grade 11 syllabus, the first lesson is complete. So I want you to do the exercise 1.1, 1.2, and 1.3. That means all the exercises in the first lesson. I want you to do and send. You can send me on WhatsApp. You can send me the answers on WhatsApp. So that I can check. So please do the exercises. And we will be meeting again on next week, next Sunday, again at 7 p.m. sharp at 7 p.m. So I want help from you guys also. I want you to share the class. You have the Google form, right? So I want you to share the Google form among your friends. So you might be having, English medium friends. So I want you to share, and if you think the class is good, I want you to recommend the class to your friend. That's only if you think the class is good and useful, you can recommend the class. If you think it's not good, obviously you don't want to recommend. So anyways, we can wind up the session now. So next week we will be starting logarithm and indices. So we have 4 lessons to be covered, right? In grade 10 we had logarithm and indices, and in grade 11 we have logarithm and indices. So there are 4 lessons to be covered. So I hope we can cover it from at least like 2 days. I think it will take 2 days. So let's see. So we will try to cover it from 1 day, but the thing is, like, it's important that you understand. So that is the thing, like, I have to do step by step. So yeah, so it's late, so we can wind up the session now. So again, I'm telling, please recommend the class to your friends and share the link among your friends. And also you can share the group link as well as the Zoom, Google Sheet link. And also, if they have any questions, they can ask. If you have any questions, you can contact me through WhatsApp. That is 078-594-2154. This is my WhatsApp, and my mobile 07777-82839. So this is WhatsApp and this is mobile. So by either method, you can contact me, and And if there's any question, you can ask me. And about past papers, yes, we will be doing past papers, but as I told you, the real numbers, there's no past paper questions, right? So whenever it is important, like so for example, triangles, circles, so these are like very important, right? Sets and probability. So in these questions, we will be specially focusing on past paper questions. But for these small sections, there's no point in wasting time doing past paper questions. So whenever it is required, whenever it is appropriate, we will be doing past paper questions. And also at the end, so after 7 months, at the 7th month, we will be doing model papers. And also when after 6 months, after passing 6 months, you will be getting quizzes. Okay. So even for the last batch, we were sharing quizzes. That means daily, every day, each and every day we share a quiz. So every day you wake up, you will get a unique learning quiz. So our students who faced the exam this time completed more than 350 questions. They completed more than 350 questions, just spending 10 minutes, 15 minutes per day. That means whenever they wake up, they have the quiz in their WhatsApp group. So they do that question and they send me the answer. I check it. So this happened for like 3 to 4 months. This happened for like 3 to 4 months. And ultimately, even without them knowing, they completed over 350 questions, especially essay type questions. So these 350 questions covered around 200 to 250 essay type questions. Okay. So that is what I'm telling. When we are getting closer to the exam, we will be focusing more on questions. But right now, the most important thing is the theory part. So first, let us get the theory online. Then we will go to past paper questions and model questions. But still, when doing the lesson, like for example, triangles, circles, when you're doing those things, we will be focusing on past paper questions also whenever required. So that thing, you leave it to me. I have already planned everything for you guys. So I will be taking you on that journey. So only thing you have to do is whenever I ask you to do this thing, you have to do that. So what I asked today, do the exercises in your book, the 1.1, 1.2, and 1.3. Because if we have physical classes, I can directly check your work. But this is online class. It is up to you. So if you want to get through your mathematics, do what I say. So do all the questions, all those 3 exercises completely. Okay. And you can send me the answers. I can check it for you. So yeah, so that's it. So I'm not wasting much of your time. So now we can wind up the session. So thank you very much for listening. Let's meet next week.
Thank you, sir.
Thank you, sir.
Yes, you're welcome.
Thank you, sir.
Yes.
Thank you.
Yes, you're welcome.